Hello, fellow space explorers. Ever looked up at the night sky and wondered, what's out there? What incredible mysteries lie beyond our pale blue dot? Today, we're embarking on a journey, not a physical one, thankfully, but a mental voyage into the fascinating and frankly mind-boggling science of interstellar travel. We'll explore the colossal challenges, the breathtaking possibilities, and the ingenious concepts that might one day carry humanity to the stars. Can you imagine traversing the unimaginable distances between stars? The sheer scale is almost incomprehensible. Think about driving across a continent. It takes days, perhaps weeks. Now, imagine that journey multiplied by millions, billions, even trillions. That's the scale we're talking about when discussing interstellar travel. But before we even get to the how, let's tackle the fundamental why. What drives humanity's relentless pursuit of the stars? Is it simply curiosity, a burning desire to explore the unknown? Undoubtedly, yes. But it's more than that. It's about survival. Our planet, for all its beauty, is a fragile ecosystem. Asteroids, supervolcanoes, even self-inflicted environmental damage, these all pose existential threats. Interstellar travel represents a potential insurance policy for the future of our species, a backup plan against the ultimate cosmic lottery. But let's get down to the nitty-gritty. What are the actual scientific hurdles we face? Well, the first and most obvious is distance. Even the closest star system, Alpha Centauri, is 4.37 light-years away. A light-year, by the way, is the distance light travels in a single year, an astonishing 5.88 trillion miles. To put that in perspective, imagine driving to the moon, a considerable feat in itself. Now, imagine making that drive over *5 trillion times. That's the scale of the challenge. Then there's the problem of speed. Our current rockets are incredibly slow by interstellar standards. Even at the fastest speeds we've achieved, a journey to Alpha Centauri would take tens of thousands of years, far longer than a human lifespan. This brings us to the need for revolutionary propulsion systems. One promising avenue is fusion power. Fusion, the process that powers the sun, releases vastly more energy than chemical reactions used in today's rockets. Imagine harnessing the power of a miniature sun to propel a spacecraft. This is not just science fiction. Scientists are actively working on fusion propulsion systems, though significant breakthroughs are still needed. Another intriguing concept is antimatter propulsion. Antimatter, the mirror image of ordinary matter, annihilates upon contact, releasing enormous energy. A tiny amount of antimatter could theoretically propel a spacecraft to incredible speeds. However, producing and storing antimatter is incredibly challenging and energy-intensive. We're talking about a technology that's far beyond our current capabilities. Then we have the warp drive, a concept often relegated to science fiction, but one that's been the subject of serious scientific inquiry. The idea is to warp spacetime itself, creating a shortcut through the vast distances of space. While theoretically possible according to Einstein's theory of general relativity, the engineering challenges are, to put it mildly, astronomical. We're talking about manipulating spacetime, something that currently lies far beyond our technological grasp. But let's not forget the human element. Interstellar travel would require generations of astronauts to make the journey. Think about the psychological and social challenges of living in a confined spacecraft for decades, perhaps centuries. We need to develop technologies and strategies to maintain the physical and mental well-being of interstellar travelers, perhaps even creating artificial ecosystems within the spacecraft. And what about the destination? What awaits us at the end of this incredible journey? We've barely scratched the surface in exploring our own solar system. The potential for discovering habitable planets, other forms of life, and entirely new scientific knowledge is breathtaking. The possibilities are endless, and that's precisely what fuels our quest. But what if we found nothing? What if, after all this effort and investment, we arrive at a barren, lifeless planet? Would that make the journey pointless? Absolutely not. The pursuit of knowledge, the challenge of overcoming seemingly insurmountable obstacles, the sheer audacity of attempting such a feat, these are all worthwhile endeavors in their own right. The journey itself, the scientific and technological advancements along the way, would be transformative. So, what's the future of interstellar travel? It's a question that hangs heavy with possibilities and challenges. We're still in the early stages, but the seeds of progress are being sown. Scientists and engineers are making incremental advancements in propulsion systems, materials science, and life support technologies. While a journey to the stars may seem like a distant dream, it's a dream worth pursuing. A dream that pushes the boundaries of human ingenuity and inspires us to reach for something beyond ourselves. Consider the sheer audacity of the endeavor. To launch ourselves across the cosmic ocean, to explore worlds beyond our own, to expand the reach of humanity into the vast expanse of the universe. It's a testament to our resilience, our curiosity, and our unwavering belief in the power of human endeavor. And who knows? Perhaps one day the descendants of those pioneering interstellar travelers will look back on our time and marvel at how far we've come. Perhaps they'll even thank us for taking the first, tentative steps on this incredible, epic journey. The journey to the stars is a long one, but the destination is worth the effort. The future of humanity may well depend on it. And that, my friends, is a truly inspiring thought.